I'm Clarissa, and I'm a rising junior at Limbrook High School, and this year my project is a robotic arm. So I thought the robotic arm would be a great intro to mechanical engineering and also learning how servos can interact with each other and with mechanical parts to do a task. And so far for Milestone 1, I have completed a robotic arm, and I've also hooked up 3 potentiometers to control the 3 servos. Now, a few problems I ran into especially concern the servos. The servos themselves are SG90s, and SG90s are hobbyist plastic gear servos, and unfortunately they are not very strong. So this arm right here is made of wood, kind of heavy. The servos can't always support this kind of load on them, and that makes them really overworked. That can cause one of 3 issues, or maybe all 3 issues, who knows. The first one being that the gears can strip. Another issue is overheating and also short circuiting. The first one is stripping. Sometimes if, for example, let's say the arm's stuck right here, and let's say this servo is trying to turn but it can't, like it's physically stuck, like there's a screw or something that's keeping in place. In that case, the gears can grind against each other, and since they're plastic, they can eventually wear each other out, and the servo won't longer work as a servo, and that's not very good. Another issue that can happen is short circuiting, which is pretty much it's just the servo's overworked, and then it just stops working. Like at one time for me, I had a voltage drop from 6 volts to 0.5 volts because one servo was just short circuiting. The third problem is overheating. What can happen is the servo becomes again overworked. It can get heated up to temperatures where it can actually melt this plastic casing right here. It does not smell very good, and it's quite annoying. But to avoid it, we pretty much have to just let the servos rest for a bit, since you don't want them to get overworked. And a second issue I had was just assembling it. These screws right here, like here, these are all like hinge screws. And the first time I made this arm, I accidentally screwed them in too tight, and that caused too much friction, so the arm physically could not move. It was just stuck, and that's just a thing, just loosen up, like, or it's not gonna work. The third issue I had was with voltage. So right here I have 4 AA batteries, and this is a voltage of 6. Before I use this, actually I use a 9-volt battery. The problem with the 9-volt battery is that though it has more voltage, it tends to have less current. And the thing about these servos is these servos really need current. And this actually provides more current than this one 9-volt battery. So at one point, these servos are actually getting 0.5 volts on average, which is not nearly enough. Servos of this size usually need about 4 to 6 volts. So I hooked up this instead, and now it works fine. So here's a circuit. In this sector right here, I have 3 potentiometers, and each of them is wired to an analog pin, since potentiometers return an analog value between 0 to 1023. And then on this arm right here, I have 3 servos. I have one A, B, and C, and each servo is hooked up to a PWM pin. A PWM pin is a pin capable of pulse width modulation. Pulse width modulation is basically digitally encoding an analog value or signal, so pretty much a value that's not either on or off. And right here I take a value from a potentiometer. Each servo has its own potentiometer, and that value I pretty much just write it into the servo using the Arduino map function. Map pretty much just, since the value from the analog from the potentiometers is from 0 to 1023, to map it from a value to 0 to 180, since a servo can rotate 180 degrees, so therefore I cannot put 1023 degrees into a servo, or that just won't work in general. Now for a demo, if I put a chess piece here, should be able to grab it using the potentiometer to control. So for example, this one controls servo A, go forward, we can open the claw, we can raise it, put it down, bring it back, go forward. Sometimes it can be a bit top heavy, small downside. And this is my progress for milestone 1. I'm pretty proud of what I have done so far, and I hope to make more progress in the upcoming 2 weeks.